Okay, I'd like to have a look here at graphing equations that look like this. X squared plus y squared equals, in this case, 25, but that can be anything. But specifically, I want to have a look at what happens when we have this business going on. Now, what we've seen, I'd love to always like to sort of look back and try to tie stuff together, but what we've just been looking at are equations of this type. Y equals x squared, and variations on that 2x squared. We've been throwing stuff in here as well and working out different facets of this, different features, but basically, what was the result when we had a, hey, what are you doing there? When you have a when you have an x squared, hopefully, you understand and you can answer that. Well, that means it's going to be a parabola, and I'm sure I have to work out where the x and y intercepts are and the turning point of all this business. But the very first thing I want you to get from all this stuff on sketching is I want you to be able to see an equation, and I want you to, like this, I want you to see a function like this, and I want you to know what it looks like. What sort of curve is it? Or in this case, in the case of this sort of function here, not what sort of curve is it, that's a straight line. So being able to see that that's a straight line with gradient 2 and y-intercept 1, this, because it's x squared, is a parabola. And that's symmetrical, and it's got all these features that hopefully we're better now, having just done a big unit on it. We're better now at doing. But now, we're now bringing in some other different types of not going into the same level of detail by any means, but we're going to have a look at 3 different types of functions now, and the graphs that result from them. And the first one is this: x squared plus y squared. When you've got both x and y squared, with parabolas, it was just x squared. Then what happens? Okay, I've kind of given the game away with the title, but let's pretend we don't have the title. Let's just start to plot some points. And what I want you to always be able to go back to is like a table of points, table of values. Table of points. Let's just gather some points, some really obvious ones. When x is 0, what's y? That sort of thing. So we could put, I'm not going to put it right in the middle, though. I'm going to put it, sorry, I'm not going to put it right over the left side, because I'm going to look at some negative values. In fact, I'm going to look at minus 5 there. I'm probably going to look at 3. I'm just going to look at some different values. 5 here. So, alright, so the easiest one is x equals 0. So plug x equals 0 in here. That means you get 0 for 0 squared. Alright, 0 plus y squared equals 25. So what's y equal to here? What squares to 25? Actually we get 2 answers, don't we? We get plus and minus 5. 5 squares to 25, but so does minus 5. So I can go and plot those points now. 1, 2, 3, 4, 5. I'm going to do this to scale just for fun. 1, 2, 3, 4. So when x is 0, did I get that right? I didn't, did I? When x is 0, x is 0 is here. 1, 2, 3, 4, 5. That's x equals 0, y equals 5. 1, 2, 3, 4, 5. So that's those points there. I've plotted those. Let's move on. When x is equal to 3, what do we get? So when x equals 3, I'm going to put 3 squared, that's 9, plus y squared equals 25. So subtract 9 from both sides, y squared equals 25 is 16. Oh, what's that? What squares to 16? Hopefully you're yelling plus or minus 4. So when x is 3, when we plug x equals 3 in here, we get y equal to plus or minus 4. So let's go to our green dot. When x is 3, 1, 2, 3, I get 1, 2, 3, 4, and I get 1, 2, 3, 4. Okay, so we're gathering some stuff. When x is 5, what do we get? 5 squared, 25, plus, remember I'm going back in here all the time, plus y squared equals 25. Looks to me like y squared equals 0 here, so y is equal to 0. When x is 5, y is 0. When x is 5, 1, 2, 3, 4, 5, y is 0 on the x-axis. Here we go. Now let's have a look at some negative value. When x is minus 5, what happens? Well, when x is minus 5, you square minus 5, you still end up with 25, don't you? So we've still got the same thing for when x is minus 5. So I'm going to have 0 here for y when x is minus 5. So 1, 2, 3, 4, 5, I've got that there. Okay, so you can see what's going to happen here if I plugged in a couple more points. If I plugged in minus 3, for example, I'd end up with 4, minus 4, and so you can see what's going on. What I have is, in fact, a circle. So what we've got is this wonderful, that's a terrible circle, but you get the idea. It's got a radius of 5, and you hopefully can see now the relationship between that radius and that number there. So what we've got, the center is at the origin. So what we have is when, I beg your pardon, so the graph for x squared plus y squared equals r squared, I'm going to put r squared there, the graph for x squared plus y squared equals r squared is a circle with center 0, 0. You can see that up here, center is at the origin, with center 0, 0, and radius, what's the radius? Radius is r. Okay, so that's it. I'm just going to go into GeoGebra here and just show you. All right, now what I've set up here is a circle. You can see up here I've got x squared plus y squared equals r squared. Now my little slider here is my value of r. So at the moment it's at 1.5. I'm going to slide it out to 2. So when I get r equals 2, when I get out to r equals 2, you can see my radius of my circle is 2. As I widen that out, it just follows the radius. So the radius is 4. Now you can see what I've done. If you look up the top left here, x squared plus y squared equals 16 is the current circle. And so as I change that value of r, see what's happening look at top left. Nothing, x squared plus y squared doesn't change. The center doesn't change. It's just my radius changes as the value here changes. So that's all I wanted to show you. We can now do exercise 7G from the work requirements. So I'll see you next lesson.